Hi, dear student. Today we are going to study the state space model for two area system. In previous module, we have studied state space model for one area system. In two area system, two areas are interconnected with some control blocks. See, here this is the block diagram AGC for two area system. Here AC1 is control for first area and ACE2 is control for the second area. So here we have the different controllers which are integrated together. So for control 1, area 1 and for control area 2 we have different variables. So together we can write this state vector x is equal to delta omega 1, delta pm1, delta pp1, delta p reference 1. This is of the first area control area variables. Delta p tile is the tap change in power because the tile line power exchange between two areas. Delta omega 2, delta m2, delta pv2, delta p reference 2 are the variables from the second control area. Now, this is the state vector of 9 into 1 vector because here we have 9 variables. Now, the separate equations you can write for each variables while seeing this block diagram. Upon the individual block diagram, you know how to write the transfer function for this so that we get the equation for this variable. For delta omega 1 is, so you will get this type, you will get this equation. So now rearrange this equation in terms of s into delta omega 1 of s. So you'll get this equation. This is the first equation. Similarly, you can write the remaining 8 equations while seeing the block diagram. Now, finally, all the 9 equations are state equation. So we can represent this in time domain. The standard form to represent in time domain is x dot of t is equal to a into x of t plus b into u of t. So this is the standard form. State bit. Now, standard transfer function for generator and load it is kp by 1 plus s into dp. Where kp is the gain constant, system gain constant, dp is the time constant. We can write the transfer function as 1 by 2 hs plus t. Now you rearrange this equation in terms of Kp and Tp. So you'll get Kp is equal to 1 by d and Tp is equal to 2h by 1. With that, state space model for two area system is completed. This is a very important question from the point of examination. Now we'll see one numerical problem. I think this two area 1 and area 2 are interconnected. The capacity of first area is 1500 megawatt and area 2 is 500 megawatt. With the incremental regulation and damping torque coefficients, which is denoted as R and D, for each area on its own basis are given as zero point 0.2 per unit and zero point 0.9 per unit. Here has to find steady state frequency and change in steady state tie line power or for an increase of 60 megawatt in area 1. Nominal frequency is mentioned, it is 50 Hz. Now, you need to convert first R2 and D2 to the base of area 1. So R2 you can convert by this 0.2 into 1500 by 500, so it is 0.6 per unit. Data we can convert. R2 you can find. So in this equation, R2 due to 0.9 into 500 by 1500, that is equal to 0.3 per. Now here you need to note that the units of R2 is per unit hertz per unit megawatt, while that of T2 is per unit megawatt per unit hertz. In order to determine the change of frequency, first you need to know change of power because of change of load at area 1. Since increase of load at area 1 is given, so you can easily find out this delta PL1. It is 60 by 1500, so you'll get 0.04 per unit. Now, change of power, sorry, change frequency per unit, it is given by minus delta PL1 by beta 1 plus beta 2. Now, beta 1 is nothing but 1 by R1 plus D1. Beta 2 is 1 by R2 plus D2. Substitute the values here, so you'll get delta omega in per unit. Now convert delta omega into hertz by multiplying delta omega into nominal frequency. Next, find change in the power between control area 1 and 2. That is given by minus delta PL1 beta 2 by B1 beta 1 plus beta 2. Substitute of all the values here, so I get delta P1. First you will get it per unit. Now convert that one into megawatt. So here you need to multiply capacity of the area 1. So delta P N1 change in power because of mechanical input and control area 1 is given by minus delta omega by R. So here you will get in per unit value. So convert that one into megawatt by multiplying the capacity of the first area. Similarly, find delta M PM2. You will get in per unit. Now convert this one into megawatt by multiplying this with the capacity of area 2. So you'll get 12.71175 megawatt. So with that, state space model for 2 area control system is completed. If you have further any clarifications, doubts, or questions, you can share through the class, Google Classroom. So we'll discuss whatever the doubts you have in the next coming presentation. So with that, I will going to complete this presentation. Thank you.